At Gradient, we are in the business of enterprise AI automation.
When you start to think about AI systems, in particular, like large language models, there's also a lot to think through from like a privacy security perspective. What exactly counts as an autonomous agent?
A non-deterministic executed path. It means that you need to have some sort of mechanism or an intelligence that can interpret the intent of the user and understand the actions and the side effects that occur in the environment to redirect the new set of execution traces.
You're maybe giving some sort of high level instruction, and then it's making decisions along the way based on what's available to determine which path to take that leads to the outcome that you're looking for.
So like the instruction overall is probably some high level goal, and the agent is tasked with achieving that. And you will grant it abilities to interact with the environment.
Hey everyone, Sean here, and today we have Mark Huang on the show. Mark previously held roles in data science and machine learning at companies like Box and Splunk, and is now the co-founder and chief architect at Gradient, an enterprise AI platform to build and deploy autonomous assistants. In our chat, we get into some of the stuff he's seeing around autonomous AI agents and why people are so excited about that space. Mark and his team has also recently been working on a project to extend the Llama 3 context window. They were able to extend the model from 8,000 tokens all the way to 1 million through a technique called theta-scaling. Mark walks me through the details of this project and how longer context windows will impact the types of use cases that we can serve with LLMs. All right, as always, if you ever have any suggestions or comments about the show, please reach out to me or Alex. And with that said, let's get over to my conversation with Mark. Mark, welcome to Software Huddle.
Hi, nice to meet you, Sean. It's a pleasure being on here, and I'm a big fan of your show.
Awesome. Well, it's good to have a fan. Sometimes you're like, when you're creating a lot of this type of content, you're like, anybody out there listening besides, my mom? So it's good that folks are for paying attention to this. So you're the co-founder and chief architect at Gradient. So I wanted to start off by just learning, what's sort of the story behind Gradient? Like, what is it? Why did you start it? Why become a founder?
Yeah, so at Gradient, we are in the business of enterprise AI automation. And the way that we do that is we leverage agents in order to provide flexible workflows that enable people to automate almost any sort of operational business task. And with that, we try to really address all the pain points that previously you would encounter when you're really familiar with like robotics processing automation, mostly because language models are just so powerful and we're able to actually break through the common patterns that existed before.
Mm-hmm. So you say enterprise AI, like what does that mean, I guess, as someone who's just learning about this stuff? Like, how is that different maybe than if I'm essentially not in the enterprise space? What are the certain things that you have to focus on because this is enterprise versus if you were doing this for, mid-market or, small businesses?
Yeah, so I distinguish it on a few levels. What I've really noticed on the long tail and the developer facing applications and products out there are that they're really easy to get started, and they're actually wonderful for the democratization and usage of AI and having people learn about it. But where they really fall short in the enterprise are the aspects of being able to grow and ensure security and data governance, and also with respect to the interoperability with integrations and just the reliability and continuous, I would effectively call it almost like continuous integration aspects of using those type of applications. And you kind of have to be a little bit more thoughtful and nuanced in an enterprise, obviously, because you are sort of beholden to your companies and your users using your product within there.
Right. Yeah. I mean, there's a ton of stakeholders involved in enterprise. And I think also like when you start to think about AI systems, in particular, like large language models, there's also a lot to think through from like a privacy security perspective. In any enterprise, the sort of requirements generally for privacy and security, like the CISO being involved, is going to be probably a higher bar than you might meet at other types of companies. So that's also something that you have to think through if you're building enterprise AI, whatever, like architecture or applications, and trying to sell in the enterprise, are you going to be able to essentially address the concerns of the CISO and the other people involved, from a security perspective, as well as some of these other things that you're talking about around like reliability, and your build, what's your throughput, how resilient is your systems, and so forth.
Yeah, for sure. And this is something I never really realized before I had to start selling to, management and going from, largely our sales process and the way that we operate is we have to sell from the top down. So in a way, we're bringing all these stakeholders along for us. We're becoming the medium for people understanding where their AI strategy should be, and also bringing the execs all to the table to understand like where's our value add there and how do we build this relationship between all the teams together.
Do you see this as being particularly tricky just because it's such a new space and many of the people you're probably talking to are interested but don't, maybe they're not experts, they don't know exactly what they even want or need?
Yeah, I'd be lying to you if I told you it was easy. I think as with all things in a way, it's a really noisy market, and it's noisy because there's a lot of disruption happening. But that's also where all the progress is, and where there's an exciting opportunity to possibly be one of the leaders and folks that people look to in terms of your brand there. So a lot of times, yeah, there's a little bit of coaching with respect to teaching folks what matters, and then being really good as a communicator for having the type of empathy for the stakeholder that you're talking to, and that requires a lot of intentionality and to be honest, like something that I was never used to. Like I'm a builder by heart. I'm a technologist, and what I wanted to do is always build incredible product. But to a certain extent, I need to build product that means something to somebody. I need to build a product that is intentional enough for them to understand how they leverage it. So I think that's probably the number one thing I've had to learn throughout this process.
Yeah, and I think that's hard. That's probably one of the hardest things for, I would think anyway, even speaking from my own perspective, like when I went from essentially engineer, academic to founding a company, was like, how do you learn the business side of the business and get good at sort of being comfortable standing up and, pitching what you're talking about, but not being scared to do that, and also not coming across as like I don't know, like a used car salesman trying to sell product. Those are hard lessons to learn, but it's starting your own company is certainly a forcing function for having to learn that stuff, or you're just not going to survive.
Yeah, I 100% agree, and super glad that you can also empathize with the situation there, because yeah, you are like, you're taking a lot of shots at goal to figure out how to position yourself too, right? And something I like, I like to tell a lot of people is like, VCs, they like to create all these market maps, and it's not really in service of just categorizing companies. It's actually for people to be able to create an understanding of how your product fits into the ecosystem and how that actually delivers usefulness or value towards the end user. And without that, right, it just seems like a bunch of chaos, because especially in a space where like 100 companies are getting started, I feel like every week, figuring out what someone even does, right? Like that's probably the first question you probably heard as a founder all the time, where you're like, someone comes over to you and the first question they ask is like, can you help me understand what you do? And as a person who's heads down building the product, and just you yourself understanding so intimately what you are, having to explain that to someone with no context, like that's a skill in itself, right? So I think that's also important too, because it does build a little bit of conviction yourself when you're the founder try to grow your company. To the whole, give me the elevator pitch, give me the one liner, like that's super important.
Yeah, absolutely. I think for me, I was kind of originally forced to develop some of those skills when I was doing my PhD, because we used to bring, guests into the lab all the time, and we'd stand up in a line and our professor would be like, tell them what you're working on in like, 30 seconds or less. So you're trying to consolidate like, 4 years of research, distill it down into like 30 seconds. And it was like the people I think that spent the understood what project that they were working on the most were able to essentially distill and condense that in a way that was understandable to anyone the best, because it really comes from getting that intimate familiarity with it and then figuring out how to like translate to sort of different audiences. And that's a real, skill set that's super, super important for all people to sort of develop over time.
Yeah, I even tell my employees to a certain extent, like with respect to how you can, like how do you grow and how do you become, the next iteration in your career and increase your impact. That's we always say, like, bring others along with you. Like the people who are absolutely the best at that, they're able to achieve great things. And I parallel that almost even to the same respect as to, how if you ever heard about the reasons why OpenAI was able to beat Google in training these large models, it's the fact that unfortunately within the organizational structure of Google, it's hard to bring others along with you. And if you could do that and you can just raise your focus on helping others understand what you need and do, like that's a powerful instrument in itself.
Yeah, absolutely. All right. So I want to talk agents. So I think like autonomous agents, I feel like they're like all the rage right now. Like, last year, maybe it was about RAG. Everyone was talking about RAG. Now we're talking about, agents, and there's a lot of articles about it and how this is sort of the future and so on. So what exactly counts as an autonomous agent, and what are some of the things that someone actually could use if they had an autonomous agent?
Yeah, so in the modern definition of what an autonomous agent is actually it is a executed path, a non-deterministic executed path, and by that it means that you need to have some sort of mechanism or an intelligence that can interpret the intent of the user and understand the actions and the side effects that occur in the environment to redirect the new set of execution traces. So it's similar to a graph, right? Like I've seen a lot of people create that pattern for um, creating agents, and a lot of it comes with being able to handle out of domain scenarios.
Okay. So this is in some ways like a maybe like a replacement for something that we might think of as like a finite state machine, where we're specific. It's a deterministic flow in that case. We're specifically telling somebody some sort of automation to take this path under these conditions and stuff like that. In the case of an autonomous agent, you're maybe giving some sort of high level instruction, and then it's making decisions along the way based on what's available to determine which path to take that leads to the outcome that you're looking for.
Yeah, if you parallel that towards self-driving cars to a certain extent, right? Like what has been the hardest part about self-driving has been the ability to plan. And determining plans just means, as you said, taking high level, typically vague and ambiguous instructions to satisfy that goal. So like the instruction overall is probably some high level goal, and the agent is tasked with achieving that. And you will grant it abilities to interact with the environment. So all the different applications of it, actually, I think, right now the really interesting ones are all related with just software applications, but the parallels to self-driving cars, to robotics, and then various systems that are almost physical to a certain extent.
Mm-hmm. And we're still fairly early in this space, but like, where do you, besides software systems, like, where is some of the initial momentum and excitement around this? Is it more sort of business use cases, or are you seeing things that are potentially consumer facing? Like, hey, like, I know I want to, yeah, I don't know, like book a restaurant on this night, or I want to book a vacation with these parameters. It needs to be tropical, and then like, hey, autonomous agent, go off and take care of this for me.
I think on both sides, I'm super excited. Either consumer facing or business facing, for the applications there, particularly for the business facing aspects of stuff. It'll completely change the way that you think we interface to AI applications today. People are really used to chatbots. I think ChatGPT conceptualized probably one of the most seamless experiences with embedding AI. But for agents, people will get used to asynchronous workflows where you're not actually waiting for the response back, and you may not actually care for the latency component there, but you're sending something out to achieve what you want. And it would be great, yeah, if I could just tell something to schedule out my entire day to a certain extent, book flights, figure out day two of my vacation, and all of that, because um, we're taking away and granting access to a lot of tedious things that maybe we don't really care to do, because they're pretty simple. And I do think it does raise the bar as a society on what are the things that we're going to be doing with all our free time, right?
Right. Yeah.
How are you gonna work alongside AI that way?
Yeah. So most of my free time is taken up with a 2 and a 4 year old. So I'm not sure. I'm still trying to figure out how AI will help me there. But I'm if there's some agent out there that could help me, I would be very, very interested and pay top dollar for. But in terms of the fact that latency potentially matters less. If I'm chatting to something like ChatGPT, I'm expecting almost, sort of real time responses, right? But if I'm saying like, go figure out my vacation, and even if it took 24 hours and came back with something that was like really, really good, I wouldn't really care that it took 24 hours to do that. So how does the fact that latency is less of a issue change the type of technology that might be involved with building essentially autonomous agents?
I think that it completely breaks the current operating patterns that people have. For one, ourselves, like, we've been doing a lot of research on long context models, because if latency is not the issue, then it does open up the door for strategies and applications that may require more compute time and latency in order to um, render the response. But if it comes coupled with more power in the reasoning, more ability to handle more data, and more ability to handle much more context, then the focus will shift much more into those aspects. And you won't actually be uh, delving in so much research into specifically cutting down the matrix multiplication speeds, and maybe focusing on other aspects of research and development.
Mm-hmm. Yeah. So I think that's another area besides like agents that now is a big topic of conversation is around like this growing size of context windows. Like there's been a ton of advancement in the last year. Like the length that was like bleeding edge a year ago is now sort of table stakes. So like, how did that happen? Like, was there particular things that happened in the research or even in, the, the companies that are leading the charge with LLMs and generative AI, something that allowed them to sort of break the barrier on what we can do in terms of the size of a context window?
Yeah, there's been a lot of different technological innovations, algorithmic too as well. Probably the first, to my mind, that kicked a lot of things off were most of the. I'll separate them between the lossless algorithms and then the lossy algorithms. So for the lossless algorithms, the first that really came about was flash attention. Probably everybody's heard of it, and that's what really pushed the context window longer than what we initially were used to. Mostly because they viewed the way that they do the computation of the attention mechanism through different chunks that are little batches that you only actually grab the set of attention that you need at the time when you need to do the backpropagation, or you actually have to do it at inference time. The second sort of class of things that have been happening is just, NVIDIA keeps on spending money to increase the VRAM on a lot of these chips. So then it just gives you, right, the requirement on that side, to be able to actually support these models. And then, on the loss, I'll talk maybe for briefly on the lossy approaches. You have quantization, which is really simple, representing a number from a particular precision to a smaller unit of precision. And then that comes coupled, though, with model degradation at a certain stage. But there's research to kind of figure out how you can ensure sparsity to uh, retain that model quality. And those are sort of the three high level innovations that have really set forth and enabled us to increase the context length. And those continue to be actually the same things that people try to innovate on today. So there's no, there's really no lack of minds trying to work on these problems.
Mm-hmm. Yeah, so it sounds like there's been both sort of innovation on the software side as well as the hardware side to help like make these context windows larger. By by having a larger context window, does that help keep models smaller?
Uh, that is a good question because I think there are two things that are happening there. In terms of keeping models smaller, I think that's more so you want the smallest model that can achieve the task that you uh, intend it to perform. But the main blocker for that is actually the amount of tokens that you train it on, in my opinion. Because if you really think about the scaling laws or even the chinchilla paper, like they're trying to find the compute optimal uh, uh, what's the compute optimal training that you need, right, at a particular model size, and then also how many tokens you need to train a model on for that. People have pushed far beyond those heuristics. And if you look at Llama 3, it was trained on 15 trillion tokens. And that has enabled you to have a more powerful model at a smaller size. And then the context window, if you increase it there, now you're unlocking like, hey, now you have a more powerful model at a smaller size that can also handle a lot of tokens at runtime. Um, and you have the other side of things, right, too, where you're people are just pushing the parameters to be as large as possible because as you increase the parameters, it's actually more sample. It's more sample efficient with the tokens. So in a way, like you're trading off the runtime costs of serving this thing in service of having something that is incredibly powerful.
And then how do people typically evaluate the size of the context window and like what's actually working?
It's still an area of open research. My company, Gradient, we really are trying to get do a lot of this work and collaborate in the open for it. In particular, like NVIDIA has their benchmark suite that we really like. For the uninitiated, the first evaluation is the needle in the haystack evaluation that Greg created, and that is benchmarking a model's ability to retrieve. It's basically passkey retrieval, where you're retrieving a key, or sorry, you're retrieving a value given a key that's just sent in a ocean of tokens, and then you ablate where that key actually is located, and then the ruler evals are even more comprehensive, where they include both needle in the haystack and then three other different types of evaluations. One is variable tracking, so you're tracking state of a variable over all of these large context windows. Another is aggregation, wherein you want to find a variable and then you want to do an aggregation on it, like counting the number of recurrences or sums. And then finally, a distraction evaluation, where it takes squad and then generates a synthetic data set in which you throw a model distracting context and still make it answer to see if you can properly answer a question. And these are really comprehensive, like, don't get me wrong, but there's even more nuanced aspects that go much more beyond what I would consider these evals looking at, which will definitely touch more on multi-hop reasoning and planning capabilities, because those are still very short context lengths.
Yeah. Yeah. The needle in a haystack one, I think, is, I mean, that kind of like showing that that works. Like I remember when Gemini was announced, they showed like essentially taking a like a black and white film and then finding one specific like frame that happened in the film. Like there's a whole like collection of jobs in certain verticals where people's job is basically to find like a needle in a haystack. Like if you think about like the legal industry, there's a lot of people that just comb through thousands of pages of stuff to try to find certain information, and it feels like that is a place that's going to change drastically in the next few years. If you can put some of that stuff into these context windows or into like an LLM, that's whether it's RAG or some other training methodology, to be able to look that stuff up immediately.
Yeah, I think we're already seeing it to a certain extent with a lot of the business use cases that we're trying to support with these models, and seeing effectively a simplification of some of the use cases we have deployed from using RAG, or actually using RAG in addition to the long context. Um, these models are getting so good actually at doing things that are derivatives of the jobs that we, the jobs to be done, right, to a certain extent. And uh, being able to expose those capabilities has really opened up the door to being able to actually be more productive and efficient for that. So I even find myself spending less time, right, like combing through gobs and gobs of pages to find the one piece of information that's relevant to me, which is a search problem to a certain extent. But I don't need to do this, the initial pruning in combing through of the documents afterwards.
Right. Yeah. I mean, there's a lot of like sort of classic search problems that you might have used like a search engine for that then point you to a link. You click on the link and then you do like essentially an internal page search or something like that to find the answer that you're looking for. And now you don't have to sort of even intake those steps and piece it together. And then that becomes even more amplified when you're talking about potentially like reams of data that exists only in a non-digitized format in a back office somewhere.
Yeah, and when you're talking about reams of data there, it really does bring up the interesting aspects of multimodality that we sort of top of mind for me and a lot of our customers to a certain extent. You mentioned Gemini and looking through frames of a video, audio modalities, sensory modalities, like all those things. If you can really kind of harness and unify the power of large models for that, you just open up the door to really interesting aspects too. And we as human beings have, uh, we're really proficient at figuring those things out, and exposing that capability within models. I think that's just like the next. We'll be working on that for the next 6 months at least, because I always say in LLM or in language model world, or AI world, you underestimate what you can achieve within a year these days. So that we're looking ahead for those aspects very, very soon.
Mm-hmm. Yeah. So, back to the actual process of extending context window. Like, if you take an existing foundation model, how do you actually go about extending the context window? What is that process?
Yeah, so what we employed personally was a curriculum learning approach where you stage different training runs to iteratively increase the context length of the underlying base model. And it all really starts out with tracking the proxy for what a context extension, as a successful context extension, is occurring. So what you do is we employed theta scaling, which is a technique for positional interpolation. Because what is happening is you have to get the model to attend to portions of its context, because they're all tokens, and properly leverage that context when in the setting when it may not have seen the new set of tokens coming in. So when you apply that, what you're doing is you're sort of shrinking down the sine and the cosine amplitude curves that are occurring, and then you're overlapping them as if they already occurred during training. And then you take these samples and you take some sort of data set, and then you synthetically generate a data set that has the new context length during training. So you're really tracking the initial perplexity curves, which are just next token prediction, to guide you in determining whether like your context length extension, you chose the right hyperparameters for that. And then on top of that, there's the distributed training aspects of managing the cluster and figuring out how to train that.
And then you did this with Llama 3, is that right?
Yeah, that's correct. We use the Llama 3 model because we found, the number one complaint about that model was the fact that it only had 8,000 tokens, which is definitely on the shorter side of what is expected from users today. And I still, honestly, I still don't quite know why they chose that context length. Maybe they're already looking ahead towards the larger model that they're going to release, or even the Llama 4 model, that might be released next year. But that model was, in particular, the best suitable candidate for us at the time, and we'd already been doing internal benchmarks to extend context lengths of models. So right after the model dropped, it was kind of a golden opportunity for us to contribute back to the community there.
And then how big were you able to extend the context window beyond the original 8,000 tokens?
Yeah, so for the two, we did the 8 billion parameter model and the 70 billion parameter model, and we hit 1 million tokens that passed all of the needle in the haystack evaluations with flying colors. We also extended the 8 billion to 4 million tokens, actually, just to to put the line, be the first to plant the flag in the ground for that. We're still improving it. Initially, there is some degradation in the model's evaluations there, and that's mostly because if you think about theta scaling, you are starting to reach the limits of floating point precision. Because if you look at our theta parameter, it's a huge number now. So think about taking a neural network and doing all these multiplications. And if you've ever had to actually train a deep learning model before, like understanding like the vanishing gradient problem and the exploding gradient problem, all those type of corner cases, they start to arise in these type of scenarios too.
How long does it take to extend the model like that?
So, with respect to the different stages of training that we used, in terms of GPU hours, I think it was in the the thousands of hours that we had to use in order to finally get to the 1 million context length models. So, it's not for the faint of heart, I would say. It's certainly, it certainly requires really good hardware and beneficiaries. We were fortunate enough to get sponsored by Crusoe, which is a GPU provider for that, and get access to a really nice cluster. And then once we had that, we were off to the races, in which we know we were going to tackle this problem and deliver something to the open source.
And what is the output? So is it essentially, you're taking the open source model and then you're generating essentially like a new version that you're contributing back?
Yeah, exactly. We have our model weights up on Hugging Face right now. I don't know what our ranking is at the moment, but we were the number 2 and number 4 models maybe a month ago when we did our release. And then to this date, we're at 100 and something thousand downloads to date. So it's been a really fruitful contribution back, and people ask all these questions about different things the models can do, even unexpected things that we want to evaluate ourselves. So it was exactly the type of release and in collaboration that we wanted, and we hope to do more of those things, and we want to learn more about people's use cases too.
Mm-hmm. And then, like, what was sort of the scale of this project? Like, I get the number of GPU hours that you had to spend like training this, but like, how many people were involved, and also how did you know that you'd actually be able to be successful? And maybe you didn't know, but like how do you kind of get started on something like this?
Yeah, so maybe I'll first say the honest truth. We didn't know that we'd be successful. We I have strong conviction that we could have done it, but it's similar to the scaling laws to a certain extent. You don't know when the scaling laws will stop. Like, are they going to keep continuing as you throw more compute and more flops to the problem? And are you going to get that deterministic improvement in models, right? With respect to ourselves, we're a small startup, so it was just a team of four of us working on this problem together for those 2 weeks. And between the day that we started to the end of 2 weeks, we were able to achieve the task at hand that we wanted, including all the evaluations too. So I'm not going to say that we didn't pull a few all-nighters in between that, because we certainly did, and we worked through the weekend to get it done. But what it really does require is intentionality between understanding like how to construct the data set synthetically. How do you set up and run empirical experiments to figure out what is the optimal network topology to use when you do this training? So if any folks are familiar with multi-node training, most people just avoid multi-node training because it's a pain in the butt. But beyond that, it's also an empirical setup where, from a system standpoint, you need to trade off and balance network bandwidth communication with your computational flops. So that was the iterative experiments we had to do beforehand, before we really started the project on other models. And then, for those 2 weeks, it was just hammering away with Llama 3 and making sure all the training runs finished successfully.
Mm-hmm. And then were there any like sort of unexpected challenges that you ran into doing this? Like where was it just smooth sailing from the beginning, or did you hit some roadblocks along the way?
I don't know if anybody who's trained these large models can ever say it's smooth sailing from the beginning. I think between figuring out how to get the correct data to how you're evaluating the models properly, and then actually babysitting the training job, there were a lot of things that we learned along the process, as well as things that got validated. So one thing was that one expected aspect that arose there is how robust the theta scaling trick works. So like, positional interpolation is kind of amazing from that standpoint, where the models really are set up for success to extend their context length if you just provide the correct data. It, I'll kind of reference something that Ilya Ilin had said to Dario, who's the founder of Anthropic, where he was basically said, like, these models, they just want to learn. So like, get the data right, get the training right, and get out of the way. And that's how like we kind of treated it. So throughout the process, it's like setting up the ablations to the experiments correctly, and then figuring out like how we need to pivot and what are the knobs we can turn in order to make sure we can do it.
What are some of the common use cases that you're seeing from like your customers or people you're interacting with around using these long context windows?
Yeah, so the interesting ones that we've really seen are particularly in the finance domain for table reasoning, where you want to answer specific questions or do an investment analysis or financial analysis on top of like many documents. And maybe it's one document with many pages, or you have to take the knowledge and link multiple pieces of information across multiple documents. And with retrieval augmented generation, the main failure node you would see there is the model's inability to disambiguate pieces of information and then combine it and synthesize it, where the lossiness that is required when you summarize context and then you kind of proxy it isn't enough to answer fine-grained questions there. And on the parallel track within like the healthcare space, there is an aspect of having models produce responses that require citations for grounding and preventing hallucination, for like plan beneficiary information. So with respect to answering questions of coverage and insurance and figuring out whether or not these thousands of pages of different documents can answer the question at hand for maybe customer service representatives or payers has been a common use case too as well. So yeah, we're surprised as to how effective these long context models could work, but for these use cases, it's just been really, really interesting to see how accurate they are.
Mm-hmm. What do you think needs to happen for like AI agents to become successful and more widely used?
I think at the lowest level, um, it's nothing different from typical software. Like you got to get your P999s in place, and you have to hit the reliability. Beyond that, from algorithmic in a model standpoint, I do think we need to improve the planning capabilities and the reasoning capabilities of these models so that they can be trusted, which relates to the P99s for longer term tasks. Because there's a little bit of um, difficulty in orienting the models and aligning them properly for their goals. Like we have found like a specific set of use cases that they're really well attuned to be useful for, but to be generally useful, there's still a lot of work to be done. And beyond one step that is related to as well are the interpretability aspects of it too. Um, they're a black box. Like we can't get around that in a way that's a feature, not a bug. But we don't want to entirely treat them as a black box, right? So we want to have some traceability there, and uh, the research needs to be done a little bit more for that in order to have fully autonomous agents working across all enterprises.
Right. I mean, as we start to deploy these things into production and have them potentially have access to sort of turn the knobs for different systems at their discretion, there's a lot of potential security issues that we have to work through if we're using agents in that way.
Yeah, and the security aspect too has to be created in line with the advancements in the models themselves too, to a certain extent, right? I'm sure you're familiar with the aspect of like tool use. Like how do you combine tool use with the fact that you have to give these models governed access to the applications it needs, as well as the model in certain ways in certain scenarios needing the context that might be data that could be user facing, right? Like you have to just have the guardrails for that down pat before release them on significant revenue streams.
Right. Absolutely. So, what's next for Gradient and some of the work that you're doing there?
I think we just continue down the path of understanding how the improvement in the long context length enables a model to learn on the fly, right? Like meta learning and in context learning is the essential emerging capability that came out in what is different about AI today, and really tie those to all the use cases that exist from AI automation in all the industries that we sort of touch on. So improving the acquisition of tool use to a certain extent, where I think it's still, most APIs for tool use are still relatively naive, where you just give it a spec and then you give it the JSON, the function signature, and then the payload coming out. But if you can provide it more context, such as documents and unit tests, like that's a much richer ability for the model to understand how to use an application or tool in service of its completing its task, which is very interesting. So you don't even need, it doesn't have to be a code completion copilot model for it to want to use that tool, right? And attaching that to what I think is the future of these agents, which is when are we going to have the time when I can just send off an agent for like 1 or 2 days and it closes a few Jira tickets or it closes your ServiceNow tickets, and like you don't even have to be bothered, right? Like, do you have to wait all that time and you can do the best work that your facilitated to do. So that combination, I'm super excited to see, and I think that's why I'm a builder in this time, because I want to see how these things affect us.
Yeah, just with a prompt, basically, just go break up my monolith into microservices architecture and redeploy on Kubernetes.
Exactly. Like that's something that I want done today.
Yeah, awesome. Well, let's go quick fire here. So if you'd master one skill you don't have right now, what would it be?
I'd say public speaking. Like it's still really tough for me to do presentations and do public speaking. I think it requires a lot of preparation on my part, and I want to get better at it.
Awesome. Yeah, I think it's just a matter of you can just get the reps in order to get there. What wastes the most time in your day?
Exactly what I was telling you with respect to the retrieval aspect of a lot of things. It's not so much like, I think retrieval to a certain extent has gotten way better, and that's where a lot of research and applications have focused on. But just like the verification step of all that tends to be hard, right? Like in a way, when you hire an employee, like once the aspect of like, oh, I can trust this person, that's almost saying like, I don't need to do the verification step anymore.
If you could invest in one company that's not the company you founded, who would it be?
Oh, that's a tough one. There's, to a certain extent, I could already invest in them, which is probably like, some of the chip makers, because I think that they're really poised to be positioned to do well in this environment. And then from private markets perspective, it's really tough because I'm so heads down in our company, and it just have so much conviction for us to be able to like, conquer this market.
Awesome. All right. And then what tool or technology could you not live without?
Yeah, with respect to that, it's the LLM services now today. Like I don't know what I would do without ChatGPT or Copilot or Perplexity. Like these are actually fundamental tools that I use every single day, that if you took them away from me right now, I would feel I feel naked to a certain extent, like doing work.
Mm-hmm. I think that's when you can tell when like a particular technology is like truly transformative. Is if you think about like the internet or mobile phone, like it's hard to imagine now that you've gotten used to having those technologies always available. And now it's, I think, like with ChatGPT and similar like copilots and LLM powered applications, like it's hard to remember what your work life or even your personal life was like before you had those technologies available to you, because you kind of become so dependent and used to having them.
Yeah, for sure.
Which person influenced you the most in your career?
Um, I mean, I'm gonna take a sentimental route from here. It's probably my father. I would. Hey, if you would have asked me 10 years ago, I probably wouldn't have said this. But perspective, like maturing in perspective has played a deep role. But sort of the aspect of like, if I really look at my relentless pursuit and uh, just my diligence for my work was built up from the way that my dad had always, he came to this country from China, built up his career. I never saw him complain or stop, but I just saw him run through walls. And then that today motivates me, like even just talking about it right now, I want to conquer everything, just thinking about how he really pursued his career. So I wouldn't be the way I am without that.
That's awesome. Yeah, I definitely think as most people, I think, I feel like as they get older, develop more of appreciation for their parents.
Yeah, for sure.
Yeah. 5 years from now, will there be more people writing code or less?
So I am going to take a middle ground, which is interesting. I think that the language of code will change actually to a certain extent. I don't think less people will be writing code, because you do need some sort of domain specific language to interface with the AI and the applications that exist. But I don't think that the current world of what we view code as will necessarily increase. Like I don't think that we're going to be people will be writing as much Java or C++ or any of that. But will there exist some interface and some lingua franca that you will have to communicate with AI more with? Absolutely. I don't think that will. There's very low probability that will not happen.
Awesome. Well, anything else you'd like to share?
Yeah, I mean, you know, call to action, I would ask people, if you're looking to evaluate long context models and you have use cases out there in terms of your enterprise, or you even want to chop it up with me and talk about like what you really think the most useful applications of AI could be for agents in the enterprise. Like, give me a call out. Visit our website and email us out. I think that we're always interested in that. Like, I care about the problems that people are facing with these things, and I want to hear about and work with the individuals that are really excited about it too.
Awesome. Well, I think that's a great place to leave it, Mark. Thanks so much for joining, and I really enjoyed this.
Yeah, me too, Sean. It was excellent. Thank you very much for having me on.
Cheers.